Hello everyone, my name is Alejandro Arbeláez.
My name is Laura Clement.
And today we are going to be talking about our paper, Transition to eBuses with Minimal Timetable Disruption. This paper is part of our project Smart Electric Buses, and we got funding from the Sustainable Energy Authority of Ireland. And we are both working in UCC, University College Cork, Ireland, and in the School of Computer Science and Information Technology. And basically, in this work, we are going to be addressing some of the main challenges that we have in order to move from regular diesel buses to electric buses. For example, one of the most popular problems that we have is that we have a maximum driving distance. In electric buses, we can go, let's say, we can drive up to 200 kilometers without recharging, which is one of the main constraints that we have in this transition.
And in order to show this, here we have a very simple image where we have two buses lines, one in dark blue and the other one in purple. Here in red you have the common bus stops. One of the solutions that we could obtain, it would be this one. If you have a look, here there are some bus stops that are highlighted in yellow. In these bus stops, we will be placing this that appears here in this picture, that is a fast charging station. And a part of providing where do we have to place the charging stations and how many, we also have to specify for how long the buses are going to recharge. And as you can see, we can place the charging stations in individual stops or in common bus stops. In order to do that, we develop a mixed integer linear program with three objective functions. The first one, the most important, is minimize the number of charging stations. Why? Obviously for economical reasons. The second one is minimize the deviation time. And this is a very important part of this paper because we want to minimize the disruptions from the original timetable to the new timetable that we provide with the implementation of electric buses in order to satisfy the customers and don't have many delays in the arrival of the buses. And the third one is minimize the number of charges done, and this is basically in order to preserve the life of the batteries of the electric buses. There are a couple of constraints here divided in subgroups. The first one is the constraint that ensures the capacity of the batteries of the buses, because basically we have to ensure a minimum capacity for reaching from one stop to the next one. The second one is the arrival time to the bus stops constraints. Basically here we want to compute when the bus is arriving to the next stop according to how long was charging in the previous stop, and also how long it takes to arrive from one stop to the other one. Also the installing charging units. Basically here we are going to decide where to install a charging unit, and the deviation from the departure time in order to minimize this objective function. We will also include some non-overlapping constraints because we have to ensure that two buses are not charging in the same charging unit in the same time.
Basically, in the evaluation, we evaluate the model, the MIP model. We use Cplex, and in the experiments, we use Ireland as a case study. Basically, we focus in three main cities: Cork, Galway, and Limerick, and we computed the solutions for some of the main roads in the main bus lines in these cities. And we also try different configurations. For example, increasing the size of the batteries. Okay, because for example, for small cities, a small battery is going to be enough, but for bigger cities, we might need a bigger capacity. And all the results are in the paper. But quickly speaking, basically, depending on the configuration and the city, we need the fast charging stations that we need. It goes from 1 to 7 on average, and basically the delays, the delay from the original timetable stop time goes from 2 to 5 minutes on average for all the experiments. And in the future, we want to explore more complex alternatives to solve the problem. For example, now we try to solve individual objectives, so we try to solve the first objective, and then the second objective, and then the third objective. In the future, we want to use more complex optimization techniques in order to get the Pareto frontier. And we also want to try to introduce, for example, uncertainties, because this problem, the public transportation introduces a lot of uncertainty. For example, there might be delays because of traffic or other situations. And thank you very much.
Thank you for your attention.